Okay, Organic Chemistry Part 2. Again, the sections and notes 22.1 to 22.6, 22-6. Do all the problems in the packet, as I said, and you're not going to do, well, a lot of it are just notes, like fill in these notes as we go along with diagrams or even the stick diagrams. You see that I'm drawing little sticks, things like that. I can't see that good, like that. But fill these in as we go. But also, there's something at the end called a self-study packet. You can tell it was made by Zumdahl. It wasn't made by me. It was made like a textbook. And that is real kind of, the copy is kind of grainy. But if you read through it, you only have to do the circled exercises. Now, if you watch all my videos, you really won't need to read through that packet. You can just go right to where the circles are and just do them. That's all, on a piece of paper somewhere. You don't have to read all that in the packet. Only the ones that are circled. So it's kind of there for people that want extra help going over it. And I thought it did a pretty good job. It'll say like, draw propane, and then they'll show you how to draw it. Then they'll tell you later, okay, now draw butane. And so they'll ask you to do one like in a circle. But, oh well. Okay, here we go. So we're continuing on from, in order, I'll just go in order of my notes here, to go to branched alkanes next. Okay, so as I showed you before, you should already know how to count and know the number of carbons, how to draw methane, how to draw methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. How to draw all those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon in a chain. Well, it turns out, I don't really have a number on this section. It might be still 22 too. Okay, for branched alkanes, you know, I almost want to jump ahead a little bit, and I think I will do that. I think I am. I'm going to tell you something that comes a little bit in the future, just to make this part a little bit easier. All right, so let's just say, first of all, before I talk about branched alkanes all the way, I want to show you, let's just draw butane for a moment. Butane, okay? 1, 2, 3, 4 carbons. So that means it will be C, 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 C. Now you know that there'll be hydrogens all around it in every position. Okay, well here's the cool thing about organic. So if I took butane and I were to react it with chlorine, guess what? I can make something called chlorobutane. A chlorine, one of the chlorine will attach to the butane. Now you could get 2 of them attaching. So actually, technically, I guess the true reaction is HCl to get 1 chlorine. HCl, and what will happen is a chlorine will take the place of one of the hydrogens on the butane chain. So don't even worry about the reaction. I told you I wasn't really going to go over reactions much. I might say a little something about those later. But let's just throw a chlorine in there somewhere. All right, let's say I put chlorine right here. All right? On the very first carbon, I put a chlorine instead of a hydrogen. So how would I draw that? In my stick diagram, I'll just draw a little line with a Cl at the end of it. Now, when you do that, what it's understood to mean is still, all of these points are carbon, 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 carbon. Remember, honk 1, 2, 3, 4. Carbons always have to have 4 bonds. This carbon has 1, 2, 3 hydrogens and one bond to a carbon. This carbon, 1, 2 hydrogens, another one to another carbon. So CH3, CH2, CH2. Now this one will have C with 2 H's and 1 Cl. So that line just means it goes to a Cl. Now if you wanted to, I mean, you could draw it that way, Cl. It would mean the same thing. It's only your shortcut diagram. Now you wouldn't want to do that really, because then it looks like it just goes to chlorine to there. You wouldn't see that carbon. So you want to at least bend it a little bit. Okay, well anyway, so what does AP want you to know about this? They want you to know how to name this compound. And I'm actually telling you something that comes in the future, so we'll come to that later. We're like, oh yeah, I think it makes it easier. So the name of this compound is called chlorobutane. It's one big word, chlorobutane. Now, it would sound easy enough if you just named it chlorobutane, but there's a number system involved here that you don't really see in this drawing. Now, let me just tell you, that would be called chlorobutane. What if I put the chlorine right here instead? It could have different chemical properties. So that would be called 2-chlorobutane. 2. What that means is, now, what we do is in the organic, we always number carbons by what's called priority. 1, 2, 3, 4, 5. So number 1 would be that carbon in this case. 2, number 3, number 4 in butane. I mean, if you have propane, you know, 3 carbons, it'd be 1, 2, 3. Or if it was pentane, it'd be 1, 2, 3, 4, 5. Carbons 1, 2, 3, 4, 5. All right. This is called 2-chlorobutane because in the chain, if I draw it here, in the chain, chlorine attaches to carbon number 2. That's number 1, that's number 2, 3, 4, 5. 3, 4. I'm sorry, 1, 2, 3, 4. It's at number 2. Now, you might say for a minute, well, why don't we name it 3-chlorobutane? Okay? I'll tell you why somebody might think that. What if you could be standing, I'm in front of the chalkboard, you're seeing this. What if you could be standing behind the chalkboard, and you look from this way, then that would be carbon 1, 2, 3. That would be carbon 3. You start counting there as 1, 1, 2, 3. Okay? So, you might say, well, 1, 2, 3 or 1, 2. Which one is better? The rule is it always needs to have the smallest possible priority number. Okay? Kind of like you want to be number 1 on the top 10 list. You want to be number 1. Okay? Or number 2, whatever. So, number 2 is better than being 1, 2, 3. So that's why we call it 2-chlorobutane. Now, for that matter, just watch for a minute. That is 2-chlorobutane. If I were to put the chlorine right there, guess what? The name of that compound is 2-chlorobutane. It's still 2. Because now I would say, well, if I go this way, 1, 2, 3-chlorobutane. If I go this way, 1, 2. 2 gives it a lower priority, so that wins out. It is 2-chlorobutane. In other words, there's no such thing as 3-chlorobutane. It wouldn't exist. Because really, 3-chlorobutane is just a wrong way to name 2-chlorobutane. So when you look at a molecule, you have to name it. Oh, and I actually have, I could actually make one here. I didn't know this, but I'll show you. And I'm tearing up my chalk. Okay. Well, anyway, this is actually propane. So watch this. If I put a chlorine, is often the halogens are green, that would be 1, 2. That would be called 2-chloropropane. 2-chloropropane right there. It doesn't work too good on this one. I was about to say, if I turn around the other way, it's still going to be that. Oh, my goodness. I don't want to... It would be great if I could build this. Well, if we were in class, I would say, hold on, let me build it real quick. Okay. Let me put bond. Oh, no. And my kids got hold of this set. I had it somewhere, and they put it somewhere. And so... they started connecting all kind of stuff to it. But let me see if it's going to work. Do I have enough pieces to show you this? Well, I can't believe it. I have just enough. Okay. Okay, so what I'm going to do, I'm going to build it for you and show you. Oh, well. I know y'all might have the point, but... okay, so this is it. If I say, what's the name of that compound? Green represents either chlorine, fluorine, bromine, or iodine. That would be 1, 2. It will be carbon number 2, chlorobutane. There it would be. Okay, 2-chlorobutane. Actually, I can make it look like the stick diagram too more. If I do like a little zigzag like that. Oh, you can't even see it that good. But there it is, 2-chlorobutane. If I turn around that way, now you say, well, wait a minute, it's not going to be 1, 2, 3 chloro. No, because it's 2, because there is 2 at carbon number 2. Up, turn around again. So you can turn it back and forth. Okay, so you have to kind of think 3-dimensionally with organic. Oh, do you ever, later on. And so that's why it's great to have a set. Okay, so that's what I want to show you. Why not throw in one more thing for you here? What if I were to have 2 chlorines? Like I told you, what if it was Cl2 and not HCl that reacted? What if this plus Cl2 reacted and you got 2 chlorines attached? Okay? Well, I could put the chlorine right there. They could go on the same carbon. Well, then what you would call it 2. First of all, you call it dichlorobutane, first of all, because there's 2 chlorines on it. Then you would call it 2, 2, and usually a dash, dichlorobutane. What that means is you have 2 chlorines attached to butane, and they're both on carbon number 2. Now, if I did 1 carbon there, 1 chlorine there, and 1 chlorine there, that would be called carbon number 2 and 3. 2,3-dichlorobutane. 2,3-dichlorobutane. Because one's on number 2, one's on number 3. And then if I want to really be crazy, let's put it over here. And now, guess what that is? It's still dichlorobutane, but it would be on carbon number 1 and number 2, so it would be 1,2-dichlorobutane, okay? So, anyway, that, I want to tell you a little bit about the prioritizing rules. Oh, I guess I'll tell you another rule. Why not, while we're here? Okay, what if I put a bromine and a chlorine? Like a bromine there and a chlorine there. What would I call that one? Okay, first of all, the chain, 1, 2, 3, 4, butane. Next of all, I've got chloro and I've got bromo. Chloro and bromobutane. Now, chloro, is it chlorobromo or is it bromo-chloro? The rule is that the attached groups will have to go in alphabetical order, okay, to make it easier. So, bromo comes first, then chloro. So it will be called bromo-chlorobutane. Bromo-chlorobutane. Now, what numbers are bromo? Oh, I'm sorry. I got to put the numbers in there. So it will be 2-bromo, 1-chlorobutane. So actually, 2-bromo. Now, technically, you'd say 2-bromo. Well, I think you can do that. 2-bromo, 1-chlorobutane. But I also know that you can, a lot of times you can leave off the 1. When it's on carbon number 1, we don't put it always, but 2-bromo, 1-chlorobutane. It'll be okay to do that. And you know what? This is beyond. What I'm going to be showing you in all this lesson, it'll be just a little bit beyond what they're going to want on AP. You don't need to know that crazy. This is going to be a little bit crazy having multiple groups. But anyway, 2-bromo, 1-chloro, because remember, they go in order by alphabet. But the numbers, of course, the 2 had to match the bromine, and the 1 had to match the chlorine. Okay, all right, so that's enough for priorities. Now, I want to talk about branched alkanes. So this will make this sound a little bit easier. Well, let me go back to butane again. What if instead of attaching chlorine or bromine, I attached a methane? Okay, what? All right, I should have kept my little drawing there, shouldn't I have? Well, I'll put it over here. 1, 2, 3, 4. So instead of putting a chlorine on number 2, let's just say that I put a methane on number 2. What I mean by that, remember methane is CH4. Methane is CHHHH. Well, it turns out every one of the groups, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane, can turn into a group if you take away one H. Take away an H, and now that carbon can bond to anything you want. I can bring the carbon over here. I'll take away the honk for a moment here. I can bring this one all the way up here, and I'll put a C there. Then I'll put an H, H, and H. There it is. So I put a C, H, H, H right there. Okay. Now, that is actually called a methyl group. So methane, CH4 is methane, we know that. But if you take away one of the H's, it becomes METH. So, sorry. What a mess. I didn't know I was going to do that. Methane, take away the H. That's methane, CH4. Take away that H, it is now called methyl group. Methyl butane. And so what you do, same as we did with the chlorine, we call it 2-methylbutane, because meaning it's on carbon number 2, not on number 1. If it were number 1, you could call it 1-methylbutane. But I normally, if they just say methylbutane, I'd always heard before, if they call it methylbutane, then you assume it's on. There's no such thing as methylbutane, by the way, as 1-methyl. There's no such thing as 1-methylbutane, okay? There's no way. Because if I put a methyl right there, sometimes you got to think about it yourself. If I put a methyl right there, then it's no longer butane, it's now going to be pentane. So there's no such thing as methylbutane. You could build it or draw it, but then you'd say, well, you're naming it wrong. But there would be a 2-methylbutane right there, okay? And that's all you can get. You couldn't even have a 3-methylbutane because, as we told you, there's no such thing as a 3 for that one. Okay, so if I attach to my compound a methyl group, then I'm attaching a CHHH. HHH. Okay, that's called methyl. And you see this on your notes on this page. Guess what ethyl is? Ethyl means you have two carbons, ethane. So start with ethane. H, 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 and H. That's ethane. So ethyl would mean I just take off one H, ethyl. And so I could actually do this. If I wanted to have two ethyl methane, and this is what AP is pretty much does. There's one question on the FRQ, and they'll say, in this box below, draw a diagram of 2-ethyl-methane. They could say that, okay? So what you would do is you would draw. Oh, I'm sorry. That's bad. Butane. Butane. I wasn't even thinking. Draw a diagram. AP would not say that. Of 2-ethyl-butane. 2-ethyl-butane. So first draw butane. 1, 2, 3, 4. Then on carbon number 2, you put an ethyl group. A carbon to another carbon. Methane, ethane. And when I'm finished, I'm going to see if this actually is the correct name, if it exists. And guess what? You know what? You guys, I am going crazy with this, but this is just showing you organic. There's no such thing. I'll tell you why. 1, 2, 3. When you name this, you have to name. I made a mistake on this, okay? This is a mistake again. But I want to show you because sometimes it's good. Sometimes a mistake can help you see the right thing. I caught myself quick. Okay. You have to count the longest continuous chain. So I'm going to change this question now. What is this compound called? So again, AP would not say draw 2-ethyl-butane because that is not a correct name for a compound. You can draw it, but then it's. Well, how about this? Draw this and then tell me the real name. Okay, what is the real name of this compound? You have to count the longest continuous chain of carbon. It would be 1, 2, 3, 4, 5. 1, 2, 3, 4. If I go that way. 1, 2, 3, 4. If I go that way. 1, 2, 3, 4. If I go that way. 1, 2, 3, 4, 5. If I go that way. So methane, ethane, propane, butane, pentane. That would actually be pentane. Now 1, 2, 3, pentane. 4, 5. 1, 2, 3. And that group is on number 3, then 4 and 5. And that's a methyl group. 1, 2, 3, or 1, 2, 3 ethyl. Methyl. 1, 2, 3 methyl. 1, 2, 3 methyl. That's methyl. It is methylpentane. It will be 3-methylpentane. That is the correct name of that. So now, this time I'm going to be right. The AP could say, in this little box, draw a diagram of 3-methylpentane. So first, you don't have to draw it this way, but you can draw it straight out 5 carbons. And then on number 3, you'll put a CH3 group coming up, methyl. Okay, methylpentane. In fact, I think I will draw it that way. Why not? And 1, 2, that's pentane. And then number 3, you have an ethyl group that looks like this. So see, and now that carbon needs 4. That carbon needs H, 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 all around it. Wow. So sometimes when I draw these and teach it, you got to really think about it, but then I'll learn it on my own. Like, oh no, that wouldn't be right. Now I have some examples on my paper where that won't happen. But it's hard to make up examples off your head for organic. But if you make up a compound, but you can actually do that when you're done with this. Draw one, and then try to name it yourself. Like, what did I just draw? Okay. Now, here's one, ethyl. Methyl, ethyl, what do you think propyl will be? Well, I don't want to draw all of these out for you, but propyl has 3 carbons. Carbon, 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 and then there's all H's on it. But then on this side, it will attach. So propyl would look like that. Now, I'll kind of get into the stick diagrams for a minute. So if I did this 1, 2, 3, 4, 5, that's pentane. And if I want to draw propyl, well, I got to be careful. I'm going to probably get into stuff that doesn't exist, so I won't do that. But propyl group, you would add 3 carbons somewhere. A methyl group would be just 1 attached to it. That would be a methyl. Okay, I attach a carbon number 1 or carbon number 2. I could attach it. If I want to attach an ethyl group, then I could go something like this. Like, say here I want to put that and that. Now, would that be pentane still? 1, 2, and ethyl, CH3, CH2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, it looks like that will work out. So that would be 2 ethyl methane propane pentane, 2 ethyl pentane. Okay, all right, and then propyl group, you attach that, and then butyl group. So methyl, ethyl, propyl, butyl, pentyl, and all that. And so you're not gonna see a lot of those. You'll get into the craziness if you start trying to attach them. Like what is the name of this new compound? All right, now, and I guess nonyl and decyl. I didn't hear about those. So you have to have a giant. It makes sense. You need a really, really long chain and put a small attachment to it. Okay, like if I had 8 carbons, octyl, I couldn't attach octyl to propane. If I attached an octyl group to propane, it would not be octyl propane. It would be something else. The octane would become the main chain, like maybe propyl octane or something. Okay, well here we go. And on the next page is the rules of it that I just told you about. The root is the longest continuous chain. Number groups by priority. Attached groups want to have the lowest priority possible. And then it says, look at the substituent groups. Use the carbon. All right, 3-methylhexane. Okay, so at the bottom, and if there's 2, use ditri, etc. So at the bottom of that page, I will do these 2. Just draw 2,3-dimethylpentane. 2,3-dimethylpentane. Now this was thought through. Now, I did notice there could be some mistakes in here, and I'll catch them hopefully right here. But pentane is 1, 2, 3, 4, 5. Then on carbon number 2, I put a methyl, and carbon number 3, I put a methyl. So there it is. 1, 2, 3, 4, 5, 2,3-dimethylpentane. It would look like that. And I'm not going to draw off the whole formula of that. CH3, CH3. Or maybe I do want to draw it. I don't know. It'll get to be a mess. Maybe I should show you one time. I don't want to scare you with it. But what I would do is I would say 1, 2, 3, CH3. You can actually say CH3 and CH3. There's 2 CH3s attached to CH. CH3 attached to CH. Then goes another CH here with the CH3 on it. CH3. I don't even know how I would do this. CH3. I guess I'll put a little thing like that. CH3. Yeah, that would do it. And then CH2, CH3. I don't think you're going to have to worry about this. But since these groups are attached to the main chain is CH, CH. Well, it's not your longest chain, but the main skeleton here, those are those 5. CH, CH. 1, 2, 3, 4. I'm sorry, 1, 2, 3. I'm looking at those 4. CH, CH, CH2, CH3. CH3, 2 of those attached to that one. Then that one has a CH3 attached to the CH. Then CH2, CH3. Don't worry about that. You're not going to have to translate. But you're certainly not, because they don't even ask you to draw this in AP. They don't even accept that as a drawing, but that little line diagram. So, oh well. Okay, 4-ethyl. 3,5-dimethyl nonane. Okay, with a nonane, I'm probably safe for this. 1, 2, 3, 4, 5, 6, 7, 8, 9. CH3, 2, 3, 4, 5, 6, 7, 8, 9. So CH3, and all the ones in the middle of CH2s, right? As of now, that's nonane. Now on carbon, first of all, notice this. E, and look at methyl. Oh, I didn't tell you this rule earlier, I don't believe. So this is another part of the rule, just so you'll see. You have an ethyl group and a methyl group. They're in alphabetical order. E comes before methyl. E comes before M. But now you see the di, you might say, well, wait a minute, di. So you ignore mono, di, tri, tetra, penta. When you're doing the alphabetizing, you ignore mono, di, tri, and tetra. Now, so that's why this is true. 4-ethyl. So 1, 2, 3, 4. You get CH, 2 carbons. So CH3, CH2. That's an ethyl group attached to that. Then you have 3,5-dimethyl. So 1, 2, 3 has a methyl. 4, 5 has a methyl. No name. So now we're starting to look like cave drawings there. But there it is. That was how it would be. The most fun thing would be if you draw this and then you build it with a set. You know, you put it together, all the pieces. Okay. All right. So I think I've told you all the rules about naming, and more than you'd need for AP. I really doubt you're going to have to draw something with multiple attached groups. But at least you know mono, di, tri. You ignore that when you're doing the alphabetizing. If I had a chloro on there too, then chloro comes even before ethyl and that, you know. I could have, you know, a trichloro or something like that, and it would be trichloro, you know, before it would come first, alphabetical order. All right. Okay. So, let's see what, watch my timer here. I can do a little bit more stuff. Let's see on the next page where we are. Okay. Oh, all right. So here we go. Now, alkanes, cyclic alkanes. All right. Okay, cyclic alkanes are the next part. And this is a neat thing, and I haven't seen a whole lot of this on AP. But I want to show it to you anyway. Now, it turns out that there are some compounds that can exist like this. Look at that. What is that? That's a triangle. Well, no, it's a C, 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 and that will be a H, H there, an H, H there, and an H, H there. Every carbon has 1, 2, 3, 4 bonds, and that will be, how would I even draw the formula for that? C, well, I'll just do it this way, C3H, 1, 2, H6. Now, you might remember C3H8 is called propane. This is called cyclopropane. Now, important. Cyclopropane is not an isomer of propane. Remember, an isomer, they have to have the exact same molecular formula. C3H8 and C3H6 are not the same. So cyclopropane, we just call it that because it's 3 carbons. So when it goes to the cyclos, they're not going to match to other formulas. So if they say draw an isomer of propane or whatever, well, there aren't many of propane, but oh well. I'll just say it's not. When we get to pentane, it will make more sense. Okay, pentane or butane. Draw an isomer of pentane. Cyclopentane is not going to be an isomer of pentane. Okay. So all right. So what we'll do. Let me move on to the other ones. So cyclopropane looks like that. That would be cyclobutane. Cyclopentane, isn't this really cool? It's a pentagon, so it works out. So 1, 2, 3, 4, 5 carbons, and then be CH2, CH2, CH2. See, propane, pentane is C5H12, and that's not C5H12. That is C5H10. Is cyclopentane. And haven't you heard of this before? What is this? No, it's not a stop sign. It's cyclopropane. Cyclopropane. You may have heard of that before as well. All right, so cyclopropane, vela, hexane. I'm so sorry. Propane was there. It's 6. I'm very sorry. Cyclohexane. You probably heard of that. Cyclohexane is a solvent, a liquid that many organic compounds can dissolve in. Okay, so and you might hear some medications that have this as well. But 1, 2, 3, 4, 5, 6. Sorry about that. Cyclohexane. All right, and what's next? I'm not going to go any further than that. There will be a heptane, octane, and all that. I don't want to try to get and draw it. Now, branch cycloalkanes. It says give the lowest priority to all attached groups. Well, I think now I'm going to be going beyond AP a bit, but I'll at least show you a little bit of this. And I put down below, and the first one is not the correct name. I called it myself already. I did my homework. This is actually called 1-propyl 2-ethyl. 1-propyl. So it says on your paper 1-ethyl 2-propyl, but that's not correct. It should be 1-propyl 2-ethyl. Or either that or I changed my mind. 1-propyl 2-ethyl. That's not, no, that's not in alphabetical order. It is ethyl propyl. It is not in alphabetical order. Sorry, it is ethyl propyl. It has to be. Oh, I know what it is. Maybe the numbering is wrong. All right, so let's draw it. Let's just draw this, and I'll see. Ethyl propyl cyclobutane. All right, ethyl propyl cyclobutane. So I want to draw. It says 1 ethyl and 2 propyl. We're going to see if this number is right or not. So the question would be, is this the correct name for this compound? 1, 2 propyl. I think the numbers might be flipped backwards, but we'll try and draw it. So first I'm going to draw cyclobutane. So that's going to be 4. Now, on number 1, I'd put an ethyl. So let's just say I put, and then on number 2, I'd put a propyl. Oh, I know why. It's 1, 2. Yeah, I know it's 2, 1. Okay, I'll tell you why. In a minute, I'm going to tell you that. Well, I'll tell you why. But first, I'll show you this. 2 ethyl, 1 propyl. 2 ethyl, 1 propyl cyclobutane. So, I'm going to let, on my circle, okay, let me start it over again. And I'll just start it over again. Okay, draw 2 ethyl, 1 propyl cyclobutane. There's no such thing as 1 ethyl, 2 propyl. Well, that's the incorrect name of that compound. So a lot of this craziness goes in. But 2 ethyl, 1 propyl. So how would I draw this? First, you draw the butane. Now, what you do is you have to pick a carbon and let it be number 1. Let's just let that one be number 1. Okay, 1, 2, 3, and we'll go clockwise. 1, 2, 3, 4. If that's number 1, that's going to have the propyl group. So methyl, ethyl, propyl. Okay? All right. CH2, CH2, CH3. Then number 2 will have the ethyl group, methyl, ethyl. Isn't that crazy looking? Okay. Now, the reason why the numbers have to be that way is the group with the larger molar mass, the larger molar mass has to be given the lower priority. So on the top 10 list, if you're a bigger molar mass, you're number 1. So propyl is number 1 over ethyl. So we get to call that one carbon number 1. It needs the lowest number possible. If that's number 1, then ethyl would be number 2. Now the other thing you could do, you could say, well, what if propyl's number 1? If that's number 1, then number 2, number 3, number 4. What about calling it 1 propyl and 4 ethyl? No, because then ethyl and propyl both need to be as close as they can to the top of the list, to number 1. And the biggest group has to be number 1. So it's 1 propyl, as we went there, methyl, ethyl, propyl. And then 2 will be the next best thing, ethyl. So what I'm kind of saying is, if I put it right there, it would still be 2 ethyl, 1 propyl. Okay? This is beyond for the AP, I'm sure. But, I feel like if you can do this and draw these, and you'll be able to do the ones in the worksheets, then you're in great shape for the other. Now, I'll show you, since this is a shorthand form anyway, I'm going to show you something else that you'll see as organic short form. You'll like this, maybe. But people also could draw something like this. Like, instead of propyl, they can put a line and they put CH2, CH2, CH3. That tells you methane, ethane, propyl. That's propyl. And then a shortcut to draw this one would be attach CH2, CH3. And of course, a shortcut for a methyl would be just to put, if I want to put a methyl there, I'll just put CH3 only on that side. But that's not in the compound, so I won't do that. All right. Oh, boy. All this crazy and scatterbrain stuff. Then there's one more on this paper, and then we'll move on. And it says, oh, wait. What is that? 1,1-dimethyl. 2-propyl cyclopropane. 1,1-dimethyl. Oh, it looks like I was putting a different compound. Well, just put 1-isopropyl 3-methyl cyclohexane. So start backwards. Start at the end. Cyclohexane is going to be the first part we do. Always draw them backwards. Like start with the end part. Here's cyclohexane. Then what you're going to do is on carbon number 3, you're going to have a methyl group. So 1, 2, well, let that be 1. 1, 2, 3 would be a methyl group. So that's going to be a methyl. And then on number 1, you want to have not propyl, but isopropyl. So if it were propyl, it would be, now propyl, this is not the right one, it would be 1, 2, 3, methane, ethane, propane. But since it's isopropyl, what's going to happen is this, you might remember this from earlier, it's going to look like that. You're going to attach to that center one. Okay, anyway, that's it. I'm not going to go any crazier onto that. We went a long time on this part. Now, I think I can show you Alkene Alkyne. I'll try and get this one little bit more done. All right. This is a little bit more relevant, but also something that I don't see a whole lot on AP. Alkene and K-Y-N-E. Alkyne. Alkene Alkyne. Okay, the alkanes are methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. The alkenes, the word changes from alkane to alkene if you have a double bond in it. So, for example, let's just start all the way with let me see. Let's start with ethane. Okay? All right, so ethane looks like this. All right, now what if I have a double bond? Well, now, remember, because it's honk 1, 2, 3, 4, every carbon needs 4 bonds. And what if you have a triple bond? It looks like this. Look at that. This is called ethane. This is called ethene. This is called ethine. Ethine. Ethane, ethene, ethine. So if you have a double bonds, you call it ethane, ethene, ethine. You do it that way. A double bond is ethene. A triple bond is ethine. Right there. Now, okay, so let me talk about how this can get a little bit crazy. I'm mainly going to look at the double bond ones, alkenes. So, no problem. There is no such thing as methene, because there can't be a double bond when there's one carbon. So ethene is the first one you can start off with. I'll keep it there. Here's ethene. But what about propane? If I go to propane, I put a double bond. We can say, well, I can put it here, or I can put it there. Now, it's only going to be one. So what you do is, it's kind of the same way we did with priority before. You want to give the double bond the highest priority number, like number 1 on the top 10 list, up to closest to number 1 that it can get. So that would be, now the only thing is you don't have to really worry about it on this one because there's only one place to put it. If I put the double bond there, it's called propene. Or I guess it's better to say 1 propene. 1 propene. If I put it right there, it's still called 1 propene because we're going from the other direction. It's still 1 propane. I could have this though also. If you have 2 of them, it changes to propadiene. So propadiene. Now you can't have 3, but if you could magically do that, it'd be propadiene, propatriene, etc. But you know, ene, diene for 2, and triene. That's about as far as you're going to have to go for this. I don't think you have to worry about any more than that. So anyway, 1 propene would be that. But let's go to butane. And I think that's on your paper. Oh, I have ethane, ethane, butane, butene. So butane looks like this on your paper. So butene, now there's other ways to draw it. I could put the double bond right there. That didn't do too good with my little stick diagram. I could draw it that way, and that would be butene. You can call it 1 butane if you want to, but as I told you, well, we'll call it 1 butane. I think you can leave off the number when it's only one of them, but 1 butane. But you know what happens, I'll tell you this also, why I'm not so worried, but what they mainly do on AP is they give you the name and have you draw it. they really don't draw it and ask you the name of it, okay? Now, there might be some exercises like that, and I do, yeah, on the worksheets there are. You want to practice it and go over it and see. And but it's mainly the other way around. But anyway, because when it's easier to do it when you have the name, it's easier to draw it. Then, like you saw a minute ago with me, when I was drawing them and I was making up them, like, oh no, that's not really the name of that. Okay, okay, but 1-butane. So if I put it in the middle, now it will be called 2-butane. Because the double bond starts at carbon number 2. Here, the double bond starts at carbon number 1. Now, as we said earlier, what if I went backwards, 1, 2, 3-butane? Well, there'd be no such thing as 3-butane, because what that really would be is that would really be 3-butane would really be 1. 3-butane would really be 1-butane. Okay, and I'll try and show you this with the double bond as well. So in a double bond, what we do when we build them is we put these longer bonds, and they actually bend. It's kind of a neat thing. So like that would be like a double bond right there, and then I put my H's on each side. So if you had to draw 1-butane, if you had to build 1-butane, wow, I am just tearing up this chalk. I'm not paying attention and with my holding in my hands too much chalk. But actually, we're almost done with this section. Okay, all right. So if I drew that, that would be it right there. Oh no, and that would be pentane. Oh no, I had 5, I didn't have 4. Ah, okay. Well, now you're thinking, well, I don't want to sit here and watch you play with toys. Okay. Well, here it is. So, but there it is. So you'd know that would be a double bond. Butene, carbon number 1. The double bond starts at carbon number 1, 2, 3, 1, 2, 3, 4. Butene, 1-butane. Okay, now, all right. So let's see. Where are we? Let me finish this bit out. Oh, I forgot to tell you about this. This is a big deal. There is, and actually, my name for okay. Oh, okay. I told you 2-butane a moment ago, and I forgot to add this on. So let's just say we draw. Okay, let's draw 2-butane. Well, there's 2 ways to draw 2-butane. 1, 2, 3, 4. And I didn't really bring this up. I put it there. But you could also do this. Like, what? What are you talking about, Vela? Well, I better show you this one. Oh, no. I'm going to have to build this for you. Can you see? All right. What happens, I'll draw it for you, then I'll tell you the name of these 2 things. Okay, I'll build it for you, then I'll tell you the names. Okay, so I'm going to put that in the middle. So let me just take that one off. Let me put that one over here. Put that one right there. Ah, that wasn't too hard to do. Okay. Now, this is also called butene. 1, 2, 3, 4. But here's a weird thing. Now, as you see, the organic models match something else that we believe is true in chemistry. And we'll talk about this in the next chapters of chemistry, AP. That these bonds can all rotate around, just like we're doing right now. But guess what? The double bond cannot rotate. It can't. So what it means is these 2 groups, even though they can move, they're trapped on this side of the double bond. They can never move to the other side. Okay, so when the 2 groups are both on the same side of the double bond, we call it cis-2-butene. CIS. CIS. When they're on opposite sides, oh, and that's not even cis. This is cis. Cis-2-butene. I just say, well, they're like twin sisters. They want to be together. Sisters, haha. So they're both together. Either both on the bottom side as I drew it, or both on the top side. That's cis-2-butane. This one is called trans-2-butane. And what that means is they're opposite. Now, trans means opposite. So I'm going to put 1. And I'll try to build this and show you. All right. Now, here's my double bond. And notice one of these big CH3 groups, whoever's on the bottom and one's on the top, they're opposite now. So if they're that way, it is called trans-2-butane. Trans. So trans-2-butane when they're on opposite sides. One's on top, one's on the bottom. Okay. And so the cis and trans talks about the biggest groups that, like, the 2 biggest groups are opposite, and the two biggest attached, if you consider them attached groups, they're not really attached groups, but if you consider them attached groups to the double bond, if the two biggest are opposite, it's trans. If they're both on the same side, then it's going to be cis. Okay. All right. And the last one, oh no, it's not quite the last one. It says to do 2,3-pentadiene. And I told you about this a moment ago. 2,3-pentadiene. So first draw pentane. 1, 2, 3, 4, 5. Now diene means there's going to be two double bonds. One starts at carbon number 2, and one starts at carbon number 3. So it would be like that. One there and one there. All right. 2,3-pentadiene. Now my next page. I just have a few things I drew on there quick, and I'll just show you. We're not going to go as crazy with this one. For the alkynes, a triple bond. So if I start with ethane, I already showed you this. Well, ethine is C with a triple bond. So ethane is just 2 carbons. Ethine means you put a triple. Now for a triple bond, I will show you one other. I guess maybe I'll show you this one little bit. I'll draw one more thing if you guys can bear with me. I'll build one more thing. All right. With the triple bond, with a triple bond, there actually is, you don't have to worry about cis and trans. There's no such thing in that one. I'll show you why. Okay, I'm there now. So on a triple bond, there it is. Look, there it is. And on a triple bond, notice that they're not on opposite sides. They're just one there. They are opposite. They have to both be there. But there's not 2 ways to make it. That's what I'm trying to show you. The triple bond looks like that. And they're 180 degrees apart. And that's also significant. Something we'll talk about in a later chapter. This, by the way, ethine is also called acetylene. If you see on the paper, acetylene. If you ever see, go to a mechanic or wherever, and you see them doing welding, and they're wearing that big mask in front of them, or whatever. I don't know if it's really a mechanic. It could be anybody working with that, metals or whatever. That gas they're burning is called acetylene or ethine gas. Acetylene is the common name for it, and ethine. And the last one, it says to draw 2-pentine. 2-pentine. And to do that one, 1, 2, 3, 4, 5. And again, you have to use the number, not you have to use the number to tell where the triple bond starts. 1, 2, 3, 4, 5. And number 2, you get your triple bond. So it'll be like that. 1, 2, 3, 4, 5. 2-pentine. And again, you don't have to worry about cis or trans because it's just going to be a straight line right out. There's no other place to put them. All right. Well, wow. We did all of that, and boy, did I go crazy with some naming stuff there. But on the next lesson, we'll get into the functional groups, and that might be the last lesson. Maybe I can do this in 3 lessons. I'll see you guys.